WASSCE 2023, May-June, Elective Chemistry, question number 2C. I. State the law of definite proportions. II. What volume of stock HCl with percentage purity of 36% and relative density 1.18 would be required to prepare 2.0 dm cube of 0.25 mole per dm cube HCl. Molar mass of HCl is equal to 36.5 gram per mole. The I part of the question says that we should state the law of definite proportions. Now, definitions and laws have to be memorized and stated the way they are. But make sure that you always understand thoroughly anything that you commit to memory. So the law states that the law of definite proportions, also known as the Proust's law, states that a given chemical compound always contains its component elements in a fixed ratio or proportion by mass, regardless of its source or method of preparation. Okay, so here, in order to understand this law very well, I'm going to use two compounds to explain. The first example compound I'm going to use is H2O, which is water. H has relative atomic mass of 1, oxygen 16. The composition of water is always hydrogen and oxygen. Now, the mass ratio is always 1, the mass of 1 for hydrogen against the mass of 8 for oxygen. So let us calculate to appreciate this. Now, hydrogen, we have 2 of hydrogen in water. So 2 times its mass, then is 2. Then the oxygen, we have 1. So the mass is 16. So this gives us 2, 1, 2 is 2. This is 16. Now, ratios can be converted to fractions. So it's going to be 2 over 16. 2 goes into 2, 1 goes into 16, 8. So it's equal to 1 over 8. And the 1 over 8 is 1 is to 8. So that is how come we had this ratio by mass. The second example, we are using carbon dioxide. So the relative atomic mass of carbon is 12. That of oxygen is 16. The composition is always carbon and oxygen. Mass ratio is always 3 for carbon and then 8 for oxygen. Let's do the computation. Here we have 1 atom of carbon, which is 12. Here we have 2 atoms of oxygen, that is 2 times 16. So this gives us 12 is to 32. When converting to fraction, we have 12 over 32. Now, 4 goes into 12, 3. 4 goes into 32, 8. So it becomes 3 over 8. So we have 3 is to 8. So that is how come we had the ratio to be 3 is to 8. So in this question, you are only to state the law and not the computation that I included here. II. What volume of stock HCl with percentage purity of 36% and relative density 1.18 will be required to prepare 2.0 dm cube of 0.25 mole per dm cube HCl. Molecular mass of HCl is equal to 36.5 gram per mole. Okay, now let's come to the solution. So the solution, percentage purity. according to the question, is 36%. I will explain that later. Relative density of HCl, according to the question, is 1.18. Relative density is equal to density of a substance over density of equal volume of water. So in this case, relative density is density of the HCl, which we represented with this, all over density of water, which we represented to be that. So here, relative density is equal to density of HCl over density of water. Now, everything is over 1. So this is over 1. So we do cross multiplication. So this times 1 gives us density of HCl being equal to this times this, going to be relative density times density of water. Now, the density of water is constant. If it is gram per centimeter cube, then it is 1. If it is expressed in kilogram per meter cube, then it is 1,000. In this case, we are going to use the 1 because our measurement is in centimeter cube. So here, the density of the HCl is equal to the relative density, which is 1.18 times 1 gram per centimeter cube. So this gives us the density to be 1.18 gram per centimeter cube. The density of HCl, which is 1.18 gram per centimeter cube, it is mass concentration, which is not standard. We need to convert it to standard mass concentration. Now, this 1.18 grams over 1 centimeter cube. So that's the meaning of this. Okay, so we need to convert only the denominator to dm cube. And the rate or conversion rate is 1,000 centimeter cube is equal to 1 dm cube. So what do? We have to, then 1 centimeter cube will be equal to 1 over 1,000 centimeter cube times 1 dm cube. So it's going to give us 1 over 1,000 dm cube. So this becomes 1.18 over 1 all over the dm cube. So this is grams. And then over the dm cube is 1 over 1,000. Then this now becomes what? Dm what? Cube. So let us continue with the computation. So here it becomes 1.18 over 1 divided by 1 over 1,000. Let's introduce bracket. Then this now becomes gram per dm cube. Now, this is equal to 1.18 over 1 times, then we reciprocate. It's going to be 1,000 over 1 gram per dm cube. So this is equal to, we multiply the numerators. So when we multiply the numerators, it is going to be 1.18 gram per dm cube. So this is the standard mass concentration for the HCl. I stated earlier that I'll be explaining these aspects as we move on. Now, when you have a substance A reacting with a substance B, producing a substance C. For instance, if we have 5 grams of substance A and substance A is pure, meaning that the 5 grams of substance A is pure. So all the 5 grams will react with B to produce C. So it is only pure substances that react. Impure substances doesn't react. Now, so for instance, if we have this 5 grams and then 3 grams is pure plus 2 grams which is impure, making a mass, total mass of 5 grams, it is only the 3 grams that will react with B to produce C, leaving what? This, which is what? Impure. So the beginning part of the question says that the stock solution is made up of 36% purity. So this tells you that the mass concentration that we have calculated for the stock solution contains impurity. So it is only the pure aspect of this that is going to react. So it is going to be 36 over 100 times this. So we are going to say that the mass concentration of the stock solution that reacted is equal to P, full stop. So P is equal to, so we have 36 over 100 times 1180 gram per dm cube. So here we are going to multiply this by that. So this gives us 0. When we divide this by this, 0.36 times 1180 gram per dm cube. So when we do the multiplication, it gives us 424.8 gram per dm cube. Okay, so this is the mass concentration, that is P, mass concentration of the stock solution that was diluted. So concentration of the stock solution is equal to Ci is equal to mass concentration over the molar mass, over the M, where M is the molar mass of HCl, which is what? 36.5 gram per mole. So in this case, the concentration of the stock solution, which is I, is equal to, this is 424.8 over the molar mass, which is 36.5, and then it's going to be mole per dm cube. So Ci is equal to, when we do the division, it is going to give us 11.64 mole per dm cube. Okay, now a stock solution is a solution which is to be diluted to get a diluted solution. Okay, so a stock solution is highly concentrated. So more of distilled water has to be added to it to create a diluted solution. So in this case, we use Ci to represent the concentration of the stock solution. And then Vi, volume of the stock solution. And then Cf, concentration of the diluted solution. And then Vf, volume of the diluted solution. Now here, I want you to take note of this. When you dilute the stock solution, the concentration changes. The volume changes. So here you can see that the volume will be more than the stock solution. But the amount of substance, which is the mole in the two solutions, remains the same. So how do you calculate for mole? Mole is concentration times concentration in mole per dm cube times volume in decimeter cube. So it's the number of moles. Here we have concentration. We have the mole in the stock solution being equal to the number of moles in the diluted solution. So we are making VI, that is the volume of the stock solution, the subject. So it is going to be concentration of the diluted solution times the volume of the diluted solution divided by the concentration of the stock solution. So we say let CF is equal to concentration of diluted solution. VF is equal to volume of diluted solution. CI is equal to concentration of stock solution. VI is equal to volume of stock solution. Okay, so here we now have this to be the formula. So the volume of the stock solution we are looking for, it is this one. So let us substitute the values. So we have VI is equal to concentration of the diluted solution has been given in the question to be 0.25. So 0.25 mole per dm cube. So times the volume of the diluted solution to be 2.0 dm cube. So times 2 all over the concentration of the stock solution, which we have calculated to be this. So 11.64. So it's going to be in dm cube. dm cube. So Vi is equal to, now when we multiply the numerators, it is going to give us 0.5 all over 11.64 dm cube. When we do the division, it gives us Vi is equal to 0.043 dm cube. So that is the volume. Or if you want to convert this to centimeter cube, then we have to multiply by 1000. So we say or volume of stock solution is equal to 1, 2, 3. By multiplying by 1000, it gives us 43 centimeter cube. Therefore, the volume of the stock HCl solution is equal to Vi is equal to either 0.043 dm cube or 43 centimeter cube. Subscribe, like, share, and discuss with your friends. Thank you.